Bismillahirrahmanirrahim. Today we are going to speak about the algebra of matrices. And algebra, we mean that we are going to speak about the addition, subtraction, and multiplications, or multiplication of the matrices. There is no division for matrices, only we have addition, subtraction, and multiplication. Start with the definition of the addition and subtraction, or the equality of the two matrices. Then we are going to speak about how to add two matrices and how to subtract two matrices. The product of the two matrices will be in the next part. So start with the definition. We have two matrices, A written as this notation, Aij. As we know, for the matrices, we have the size of the matrix, which is the number of rows multiplied by the number of columns. And the elements are written in this notation, A sub Ij, means the first index, this one, I is for the row and J for the column. So we have row and we have column. The location for the element start with the row first, then the column. And so with that we have this matrix A equal to Aij and B, which is equal to written in this notation, B sub Ij. We say these two matrices are equal if and only if Aij equal to Bij. It means the elements in the same locations must be equal. The element in the same location. And this should be for every I and J. For example, suppose that we have this matrix. A is equal to A minus 2B, 3, 3, and 1. And B is equal to 3, X minus 4, 3, X minus 4. This is the first row. Second row is 3 minus 1 and Y. Then A and B, or A is equal to B, if and only if. These have the same location. The first element in the first row must be equal to the first element in the first row of the second matrix. So we are looking for the element in the same locations, and this must be equal. So A must be equal to 3. First element, first row, first column equal to the first element in the first row, first column of the second matrix. And B must be equal to, in the same location, which is equal to minus 4. We have to look at the same location. And C equal to minus 1 and Y is equal to 1. So we are looking for again, the elements in the same location. This is the first one thing. And also, we have to think about the two matrices. They must have the same size. So the matrix A and B, if we look at the matrix A, the size of the matrix A, we have 2 rows and 3 columns. So the size is 2 multiplied by 3. I can write A of 2 rows and 3 columns. Rows and columns. B, also we have the same thing, 2 rows and 3 columns. So this is 2 rows times 3 columns. So the two matrices must be of the same size, and then we are looking for the element in the same location. If they are equal, then the two matrices are equal. If they are not equal, or one of the elements is not equal to the same element in the same location, we say that A is not equal to B. This is the first thing. Second thing, that it is the definition of the addition of two matrices. If A is given by this matrix and B given by Bij, are matrices of the same order or the same size, m multiplied by n. It means A of the size or order m by n, and B is also the same order m by n. Then the sum of the matrices is the m by n. We have the same another matrix, or the result of the addition, will be a matrix of the same size m by n, given by a sub ij plus b sub ij. We are adding the element in the same location. For example, let A given by this matrix 2, minus 2, and 3, 1, 3, and minus 2. Now the size is 2 by 3. 2 rows, 3 columns. And B also 2 by 3. So the two matrices are of the same size. If I want to add A plus B, A plus B. So we're adding 2 with the 5. Adding the element in the same location. The first element with the first element. Second with the second. Third with the third, like this. Same thing for the second row. So the result will be 2 plus 5 minus 2 plus minus 2, 3 plus 6. Second row is 1 plus minus 2, 3 plus 3 minus 4 plus 5, and I will have this matrix. Seven minus 4, 9, and minus 1, 6, and 1. If the two matrices are not of the same size, for example, C is given by 2 by 2, 2 rows and 2 columns. D is 2 by 3. So the two matrices are not of the same order. In this case, C plus D is not defined. We cannot add C and D because the two matrices, they don't have the same order. So the two matrices can be added if they have the same size or of the same order. Number of rows equal to the number, and the number of columns are the same. Next point will be the definition of the additive inverse of a matrix. The additive inverse is just can be defined as if we have matrix A, then the inverse or the additive inverse of A is minus A. Minus A. We change all the signs of the element of the matrix A. That will give me the additive. It means that if we add A and minus A, we will have 0. 0 matrix. For example, A is given by minus 2, 3, minus 1, 0, minus 4, minus 1, and 4. Minus A is 2, minus 2, 1, I'm sorry, minus 3 and 1, 0, 1, and minus 4. So the additive inverse, that we are changing the sign for each element. So if we add these together, I will have 0. They will cancel each other, and I will have 0 matrix. So from this point, we can define the subtraction of the matrices. If A and B are two matrices of order m by n, then A minus B is equal to A plus minus B. Just like that, with that, we are changing the sign for each element of the matrix B, then we add. Now for the 0 matrix, it is the matrix that noted by letter O is the m by n matrix whose elements are all zeros. All the elements are zeros. We say this is 0 matrix. For the properties of the addition, first one, it is commutative. It means A plus B equal to B plus A. It is like 2. For example, for the real numbers, 2 plus 3 equal to 3 plus 2. Because this is commutative, we can apply the same thing for the matrices. Associative, A plus B plus C together is equal to A plus B together plus C. Additive of the inverse or additive inverse, A plus minus B will give me O. All of the elements are equal to 0, and additive identity. Identity, it means the element that will not change the result. It has no effect for the addition. It is like the number 1 in the, or number 0 in the real number. 2 plus 0 is equal to 2. And 0 plus 2 is equal to 2. So we call that 0 is additive identity. Same thing for the matrices A plus O equal to O plus A, which is equal to A. This will not affect the given matrix A, because additive identity. Just for the direct application for these definitions, we can solve this example. Suppose that we are given A equal to this matrix 2 minus 1, 3, and 3, and B equal to minus 1, 3, 2, and 1, and we need to find A plus B and A minus B. Let's find A plus B. So to find A plus B, I have to take the size or the order. For the matrix A, I have 2 rows, 1, 2, and 2 columns. This is the size or the order of the matrix A. For B, it is the same. I have 2 times 2. Since they are of the same order, we can add them. So A plus B is equal to first element with the first element. So it is 2 plus minus 1. Second with the second, which is minus 1 plus 3. Now this one of the second row, 3 with 2, and 3 and 1. This will give me 2 minus 1 is equal to 1, minus 1 and 3 is equal to 2, and 3 plus 2 is equal to 5, and 3 plus 1 is equal to 4. And you can see this is 2 by 2 matrix again. So this is A plus B. Now to find A minus B. So it will be 2, or I can write it as A plus minus B. So this is 2, minus 1, 3 and 3, plus. Now I need to change the sign for the matrix B. It will be plus 1, minus 3, minus 2, and minus 1. So the subtraction is, it is addition of the additive inverse, which is equal to 2 plus 1, because we have plus, now we change the sign from negative to positive, minus B. So it is 2 plus 1 will give me 3. Now minus 1 minus 3 is equal to minus 4, 3 and minus 2. This one with this one will give me 1, and 3 with minus 1 is equal to 2. So this is A minus B, 3 minus 4, 1 and 2. Take another example. Suppose that we are given A of this size, which is 3 rows and 3 columns. This is a 3 by 3. And B is also 3 by 3. 3 rows and 3 columns. So we can add these two matrices because these are of the same order. So A plus B is equal to 0 minus 1 is equal to minus 1. 2 plus 2 is equal to 4. 0 plus 4 is equal to 4. This is the first row. 1 plus 3 is equal to 4. Minus 3 plus 3 is 0. 3 minus 2 is equal to 1. This is the second row. Now, third one, 5 minus 4 is equal to 1. 4 plus 4 is equal to 8 and minus 2 plus 3 is equal to 1. So this is A plus B. Let's find A minus B. This is like A plus minus B. So we can write A again as 0, 1, 5. Then we have 2 minus 3 and 4, 0, 3 and minus 2. This is A. For B, I will make a plus and change all the signs of the B. It should be 1 minus 3. We change the sign of all the elements in matrix B. Minus 2, minus 3, minus 4, minus 4, 2, and minus 3. Then we can add. So add 0 plus 1 is equal to 1. 2 minus 2 will give me 0. 0 with minus 4 is minus 4. 1 with minus 3 is equal to minus 2. Minus 3 with minus 3 is minus 6. 3 plus 2 is equal to 5. 5 plus 4 is equal to 9. 4 minus 4 is equal to 0. Minus 2 minus 3 is equal to minus 5. So this is A minus B. So this is how to add two matrices or subtract two matrices. They must be of the same order so that we can add or subtract.